This video is on the objective make a conclusion and interpret the results of a one-mean hypothesis test. Now this is with the population standard deviation known, right? So sigma is known here, meaning that our test statistic for a sample will be a z-score. And we'll be dealing with the normal distribution, not the student's t. And this time we're using the p-value approach, right? So remember there was the critical value approach, the p-value approach. Critical value approach, you found critical values and set up rejection regions and then determined if your test statistic was in the rejection region or not. For the p-value approach, you just find the p-value of your test statistic and then compare that p-value to alpha, the significance level, and make your decision about the null hypothesis. Do you reject the null hypothesis or not? Now this is the second video I'm doing on this. This is number 2. So hopefully you've watched the first one. This one I'm just going to go through the problem without doing as much writing as I did in the first one, and show you how to work these problems. Alright, so here's what the problem is. Again, if you want to see some more stuff, click on more instruction, look at their videos, their examples, their notes, and hopefully they help you. Alright, so we're here, so Jacqueline, a medical researcher, would like to make the claim that a newly developed prescription medication for headaches gives patients relief in 61 minutes or less on average. Alright, so Jacqueline samples 12 users of the medication and obtains a sample mean of 55 minutes. So at the 1% significance level, should Jacqueline reject or fail to reject the null hypothesis given in the sample data below? Alright, so the null hypothesis she has set up is that the mean is 61 minutes. Okay, so this is what's going to be assumed. You're going to assume the mean is 61 minutes. And then her claim is about the mean being less than 61 minutes on average. Right? I know it says 61 minutes or less, but they've just put the less here. Because remember, the alternative hypothesis doesn't involve equals. So the alternative hypothesis reflects her claim that the mean is less than 61 minutes on average. The alpha, the significance level, they said was 1%, so 0.01 here. Alright, then what happened was, she took a sample of 12 users, found the sample mean of 55 minutes, and what she did was she took 55 minus 61, minus the assumed mean, and then divided by the standard deviation, which would have been sigma divided by the square root of 12. Right, we don't know what sigma is, but we're assuming that we know what sigma is, right? Population standard deviation known. And she found the test statistic, right? The z-score for this 55-minute sample mean was negative 1.99. So this sample mean of 55 minutes is almost 2 standard deviations below the assumed mean of 61 minutes. And that's not that far. I mean, it's almost 2 standard deviations away, right? 1.99 below. Now the question is this far enough away for us to say this assumption is bad? Because if it's really far away, if our sample mean is really far away from the assumed mean, then that's probably that's telling us that our assumed mean is probably not good. Right? We should reject it. But if our sample mean is pretty close to the assumed mean, then we'll keep it. We won't reject it. Alright, so again, we're going to find now this is a left-tailed test. Alright, this is a left-tailed test because our alternative hypothesis here is that the mean is less than some value. So it's a left-tailed test. And remember, for a left-tailed test, the p-value is the area to the left of our test statistic. The area under the curve to the left of negative 1.99. Alright, so they're having us do this interactive thing, right? First we decide what it's a left-tailed test. So I move this dot here to this, come on. There we go. Left tail. Right, so you see they have the little rejection region and critical values set up. We're going to focus on the p-value though. So they have this rejection region set up. Now that's left tail, left area, left tail rejection region. The significance value level was 1%, right? 0.01. So I'll leave the dot where it is. So there's our rejection region. This purple region has an area of 1%. And if you were doing the critical value method, right, the critical value here would be a z-score of negative 2.33. All right, now you got to move the red dot to where our test statistic lies, negative 1.99. So moving this to negative 1.99. There we go. Nope, come on. All right. And then we can see very clearly, if we were doing the critical value method, we could see very clearly that this test statistic isn't beyond the critical value. Right? Our test statistic of negative 1.99 is not in this purple rejection region, so we wouldn't reject the null hypothesis. We'd say, hey, this mean of 61 minutes is good for now, right? With this one at 1% significance. But you can also look at the p-value. Right? Remember the p-value. This is a left-tailed test, so this p-value they're giving us of 0.0233. That's the area to the left of negative 1.99. That's the area to this pink area, the area to the left of the test statistic. And when you compare the p-value to alpha, 0.0233 is greater than 0.01. And remember, if the p-value is greater than the significance level, then you don't reject the null hypothesis. So we are not rejecting the null hypothesis. Now, this is not the reason, though. The fact, that because the absolute value of negative 1.99 is greater than 0.1. No, that's not why. The reason why we're not rejecting is not because the value of z is negative. That is not why we're not rejecting. We're not rejecting the null hypothesis because the p-value is greater than the significance level. That's why we're not rejecting the null hypothesis. Okay, and again, read your answer explanations. And then there's another part to this where they ask you for, okay, now that you've said this, you're not rejecting this, what's the conclusion? So use the information above. Choose the correct conclusion. Now remember, her statement was about being 61 minutes or less on average, right? The average was less than, so like her statement is the alternative hypothesis, but we didn't reject the null. So that means we're not accepting the alternative, right? We're keeping the null. So we're not accepting this mean is less than 61 minutes statement. I hope that makes sense, right? We're not rejecting the null, so we're not accepting, we're not supporting this statement, the alternative. So let's see which one of these makes sense based on what I just said. All right. So there is sufficient evidence to conclude that the headache medication gives patients relief in 61 minutes or less. Well, no, not the or less on average. The thing is, though, it does give it in 61 minutes. So technically that's true. But the less part we're not accepting. So I'd say there's not enough evidence because the less part is in the alternative. Now I'm going to do something that you can't do. I'm going to cheat and say, hey, yeah, see. So I was right. There is not enough evidence to conclude that the headache medicine gives patients relief. Really, it should just be less than 61 minutes because we said equals 61 was the null, and that is 61. But the or less part isn't true, right? We're not accepting that. We're not accepting the less part, so there's not evidence for this less than 61 minute average, right? Because we didn't reject the null. So, and again, read the answer explanations. Hopefully you can figure out where you went wrong. If you got it wrong, then do better the next time. Alright, so hopefully these couple videos on this objective help you out. when you're working on these kind of problems on your own. And thank you very much for watching.